Hello, Leiden geometry students. In this assignment, we are going to talk about inverse trigonometry. That's doing trigonometry backwards. In order to do this kind of problems, you have to already know basic trigonometry. You got to know sine, cosine, tangent, opposite, adjacent, and hypotenuse. Now, let's talk about the kind of problems we're going to be looking at. The thing that's going to be different about these problems from what we've seen before is we'll have a right triangle, but we're not going to know the angle measurements. See, in all the problems we had so far, we had a right triangle and we knew one side at an angle, and we're asked to find a missing side. But in this case, we're going to be asked to figure out stuff without knowing the angles. So in this problem, we don't know these two angles. Well, this one's actually a really easy one. How would I find x in this problem? This should be something you already know. It's something we've already done in this class. So how do we find x? Yes, you, the little hairy kid in front. This is just a Pythagorean theorem problem. See, if we know two sides and one of the third, we can just use Pythagorean theorem, plug in our numbers, and solve for our missing side. That's when we have a right triangle, we know two sides, we want to know the third side. That's an old problem. But what we're going to do that's completely new is a problem like this, where we're going to be asked to find a missing angle. Here we know the sides in the triangle, but we don't know this angle. And that's the new problem we're going to be working on. In order to understand what we're going to do, let's look at an older problem, a basic SOHCAHTOA problem. Here we have our angle 65, x is our opposite, 28 is the adjacent. So we have opposite and adjacent, we'll use tangent. We say the tangent of our angle is opposite over adjacent, plug in the numbers, and then we've been really lucky. We can just type in our calculator 28 times the tangent of 65. You didn't always used to be able to do that. The calculators didn't always have that. So what we'd have to do way back then is we'd have to turn this into whatever the value of tangent 65 is. It's some weird decimal. And the way we'd find that is we'd have a chart. At the back of every math textbook would have a chart like this, where you'd look up an angle. Say we were looking at the 5 degrees. It tells us this is the sine, this is the cosine, this is the tangent. So for the problem we were just looking at, it was 65 degrees. So we got to come over here to the 65. Here's the sine, here's the cosine, here's the tangent. It's this weird decimal, 2.1445. So we'd have to come and we'd have to plug that in for tangent and then multiply these things out by hand. And that is the method we're going to use for finding the angle. Kind of. We're just going to do it backwards. Okay, so if we have a trigonometry problem where we're looking to find the angle, we basically do the same steps. We just do one step at the end backwards. Here, we're going to start with the same way we did every other problem. We're going to pick an angle. And in this case, since we're looking for this angle, this is the angle we select. Then we identify our sides, opposite, adjacent, and hypotenuse. And then we're going to use sine or cosine or tangent. Since we have all three sides, we can use any of them. So we're going to set up all three real fast. From our angle, the sine is the opposite over hypotenuse. That's 9 over 15. We'll turn that into a decimal. That's 0.6. The cosine would be 12 over 15, or 0.8. And the tangent would be 9 over 12, or 0.75. So we're just going to focus on the decimals here and make our lives a little bit easier. And we're going to start with looking at the sine. And what we want to do is we want to look at that chart and figure out which angle had a sine of 0.6. So we pull up that chart and we start looking down the sines for 0.6. The nice thing is they kind of go in order, so it's easy to find them. So you keep scrolling until you find 0.6. We don't get it exactly right, but down here, right around 37, we get about 0.6 for our sine. It says the cosine is 0.79. We had 0.8. And the tangent's 0.7536. We had just 0.75. So it's really close to 37, but that's not exactly right. If we want to be more precise, we can use our calculators rather than looking up the chart, but we have to tell our calculator that we want it to look up these numbers backwards. So if we want to say, hey, calculator, go look up what angle had the sine of 0.6, we do what's called inverse sine. That's the sign with this little -1. That's the inverse symbol in mathematics. We say, calculator, go look up what angle has the sine of 0.6. So inverse sine of 0.6. Or we could do the cosine. We'd ask the calculator, look up the inverse cosine of 0.8. Or the inverse tangent of 0.75. How do we do that in the calculator? Well, in the calculator, if you look, you have your sine, cosine, tangent buttons. Depending on how the calculator works, in this one, inverse sine, inverse cosine, inverse tangent are right above it. It might be that you hit the button twice to get it, but in this case, it's just going to be, we're going to hit second sine and put in 0.6 in our parentheses to do this. You may be doing it using Desmos. Desmos will be a little bit trickier. If you do it in Desmos, you have to use this old term, we didn't used to call them inverse. They were called arc sine, arc cosine, and arc tangent. So this ARC, and then type sine of our angle of 0.6. Well, I think I need to put a space between arc and sine there, don't I? There we go. Arc sine of 0.6. No, I guess I didn't need that space. Where'd that go? Uh-oh, I'm messing this up. There we go. Arc sine of 0.6. And it'll give us our angle measure. So you're going to try to do this with a calculator or Desmos. Type in inverse sine, inverse cosine, inverse tangent, see what you get. It should be really close to 37, but not exactly 37. If you do use Desmos, make sure you switch. Click the little wrench and turn it into degrees, not radians. If you do it right, it doesn't matter which one you do. They all turn into the same answer, 36.9 degrees. That means this angle was 36.9 degrees. Every time we're using trigonometry to find an angle, we use the inverse sine, inverse cosine, or inverse tangent. Because inverse sine, cosine, tangent do these problems backwards. For example, the sine of A, some number, is B. That means the inverse sine of B is A. The inverse is doing the same thing backwards. So if you typed in your calculator sine of 30, you'd get 0.5. If you took the inverse sine of 0.5, it would turn it back into the 30-degree angle. If you take the sine of 60, you get this crazy decimal. So if you take the inverse sine of that crazy decimal, it goes back to 60 degrees. Sine inverse is how we do the opposite of sine. It takes these numbers, it takes you from one number to the other in the reverse sense. So the names of these things again, inverse sine, inverse cosine, inverse tangent. If you're using Desmos, you type ARC, arc, before each of these to get the inverse. Okay, so let's take a look at some problems here. Here's our first problem. We have a right triangle. We know two sides. We want to know the angle. This is an inverse problem. We start off the same way. Since we're looking for this angle, that's the angle we select. And we label our sides. In this case, we have the opposite and adjacent. We're not going to use the hypotenuse, but O and A. That's going to be tangent. So we write down our equation using these two numbers. The tangent is the opposite over adjacent. Plug in the 35 and 28, we get this. And now here's where the problem is different. When we don't know the angle, this is where we do the inverse tangent. And we just put in that fraction. Inverse tangent of 35 over 28. Again, in a calculator, you want to select inverse tangent. For our problem, I had to hit second and tangent to do it. If you have the other type, you might hit tangent twice. But inverse tangent, and then in the parentheses it starts, we're going to put 35 divided by 28 and close the parentheses to get our answer. If you haven't done that yet, please do that. And when we do that, we should end up getting about 51.3 degrees. Let's try another one, but basically the same thing. We want to know this angle, we know these two sides. Step one, select our angle, no problem. Step two, identify our sides, opposite, adjacent, and hypotenuse. In this case, we have the opposite and hypotenuse. Which trig function is that? Well, that's sine. So we're going to write our equation. Sine of our angle is opposite of our hypotenuse. Plug in the 12 and 18 to the right spots. And now to solve this problem, we're going to take the inverse sine of 12 over 18. And we should get 41.8 degrees. One more like this. So see if you can get all the way to the final answer in this problem. Okay, so step one, we pick our angle. It's the one we're looking for. Identify our sides, OA and H. We have A and H, that's cosine. So our equation cosine of our angle is A over H. Plug in the 72 and the 104. And we have to take an inverse cosine of that number. We should end up getting 46.2. There are a couple of small tricks. Neither one is very hard, but there are a couple of small things we need to address here. If we have this problem, what if you make a mistake and type something in wrong? Well, sine and cosine always have the bigger number on the bottom because the number on the bottom is the hypotenuse. So if you put this in wrong, if you put the 104 over 72, your calculator, and then try to take the inverse cosine of it, your calculator is going to say error or undefined. So if you see that, it probably means you put your fraction in upside down. Remember, the hypotenuse is always going to be on the bottom if you do it correctly. What if you have a problem where you're asked to find both the angles? Well, in this case, just do it the normal way. Pick one of them to start. So we pick angle A, identify our sides, and by the way, we could have picked B instead. In this case, we're going to use the opposite and hypotenuse, that's sine. Plug in our numbers, we take the inverse sine, and we're going to get 23.6 degrees for our angle. So how are we going to find out what angle B is? Well, you can start over and do it, or you could just make sure your three angles add to 180. So we could just make sure the three angles in the triangle add to 180. 90, that's a little one angle we know, plus 23.6, that's the one we just figured out. And B, the one we're looking for, add to 180. So just subtract these two numbers from 180, and we should end up with 66.4 for that last angle. What if we have all three sides and we need to find the angle? Well, basically, then you can just pick any of the trig functions you want. You do the problem the same way with OA and H. You could do the inverse sine of 4 over 5, because that's the opposite over hypotenuse. You do the inverse cosine of 3 over 5. You can do the inverse tangent of 4 over 3. They all lead to the same answer. All of these give 51.3. So if you're given all three sides, you're basically just going to pick which one you would rather do, sine or cosine or tangent.